Hello everybody! We're going to talk about how glaciers form. The aim of this lesson is to explain how glaciers form and to be able to draw a label diagram of a glacier. So, let's start. So, you're using Google Earth. You look at the mountains of Alaska. You zoom in a bit. You realize that there are what looks like rivers of ice. Zooming in a bit more. A bit more. It looks like the ice is moving down towards the sea. It looks like there are 3 rivers of ice. So what are these? We call these glaciers. A glacier is a large accumulation of many years of snow that has become ice. Sometimes glaciers are known as rivers of ice because they're actually ice that's traveling downhill. At the moment, glaciers cover around 10% of the land area on Earth, and glaciers hold almost 70% of all the world's fresh water. Although glaciers move slowly, they create the most beautiful scenery. They bulldoze and break through mountains and create some of the most magnificent landscapes on Earth. This is a diagram of a glacier. It is a cross-section, which means that we're looking at the glacier like we cut it in half and we're looking from the side. Glaciers, similar to rivers, behave as a system. They have inputs, stores, flows, and outputs. Let's see what these are one by one. Inputs are where the soil is added to the glacier. We call this part of the glacier the zone of accumulation because snow is added to the glacier. Inputs usually happen in highland areas near the head of the glacier. Inputs come from avalanches or snow coming down the mountain, just like that. They also can come from precipitation in the form of snow falling. We said that snow is added to the head of the glacier in the zone of accumulation. Over time, snow piles up. During fresh falls of snow, air is trapped between the flakes. As more snow falls, the underlying layers are compressed. With the weight of the snow itself, eventually, air is squeezed out of the snow. At this point, the snow becomes firmer. And over time, the bottom layers become ice. Ice without any air left in it turns blue. This photo shows the snow at the top of the glacier, snow that has just been added. You can see that air is still trapped inside, because when a person walks over it, he leaves footsteps in the snow. However, if you look at the bottom of a glacier, the snow has now turned into ice. The ice looks harder and has turned blue because there is no oxygen in it. The glacier itself also holds water inside it. We say that it stores water in the glacier itself. Water is held as a solid and a liquid. We also say that the glacier flows downhill. Ice slowly moves downhill. You can see the ice moving down this glacier. Ice moves down due to the force of gravity. So glaciers will always move downhill towards the sea. Although it seems like glaciers move slowly, they can move up to 30 meters in one day. Finally, we come to the outputs. The end of the glacier is also called the snout. Over here, we find the zone of ablation. At this point, the water from the glacier is leaving the system. Ice can evaporate when there are warmer temperatures. It can also melt and run downhill. When a glacier melts, it is called ablation. This is why we call this area the zone of ablation. Water can also leave the glacier by calving. This is when big chunks of ice fall off the glacier and into the sea. Evaporation, melting, and calving happen in the summer months when the weather is warmer. It's also been happening because of global warming. The final check. Here is a diagram of a cross-section of a glacier. You can see the numbers and the number of labels. Put the labels in the correct place. Pause the video and allow yourself 2 minutes to work them out. When you're done, press play and check your answers. Okay, so number 1 is the zone of accumulation. This is where all the inputs are, where snow is added to the glacier. Numbers 2 and 3 are avalanches and snowfall. Both of these are inputs that add snow to the glacier. At number 4, we can label it the water stored in the glacier. And number 5, glacier moves due to gravity. We finally have the zone of ablation. This is where the glacier starts melting. The 3 outputs of a glacier are evaporation, melting, and calving. Okay, remember, geography is everywhere.